Hello everyone and welcome to this Codefresh live event. You're watching Terraform GitOps on Codefresh. Our presenter today is Eric Osterman. He's a technical evangelist and DevOps guru and also the founder of Cloud Posse and a great partner and friend of Codefresh. You all are in for a treat because Eric has a very colorful and engaging presentation and demo coming your way. So with that, Eric, why don't you take it away?
Yeah, so as Taryn was saying, this is going to be a lot of fun today. I had a lot of fun putting these slides together on how we've achieved using Terraform with Codefresh to achieve GitOps. And I have a lot of slides that are going to paint a pretty picture for you. And then at the very end, I'm going to show you exactly what that looks like. So today, I want to first convince you or share what is GitOps. And I think for a lot of you, you might already be practicing. So the hint here is that it's not rocket science. If you're practicing CI/CD today, that's pretty close to what we want to do with Terraform. I'm going to then convince you on why it's totally awesome. And I think you're probably going to agree and go back to your desk tomorrow and want to try and implement some of this stuff. And I'm going to show you how you can get started. So that's going to be how you can actually implement the Terraform code in your environment. So stay tuned for the demo. That's going to be about halfway through. My name is Eric Osterman, and I'm the founder and CEO of Cloud Posse. We're a DevOps professional services company based here in Los Angeles, California. We do one thing really, really well, and that's DevOps. We're not going to build your mobile site. We're not going to do your SEO. We're just going to build pretty sweet infrastructure. And we do that because we've pioneered this awesome approach where we open source everything we do with our customers. So like every iteration we do, we take that and we open source it under Apache 2 and release it. And it allows us to move faster and faster and faster. And part of what we've done is open source over 140 Terraform modules. So you could say we Terraform, we do a lot, and we have a pretty strong opinion on how Terraform should be done. Anyways, if that sounds interesting, do check out GitOps. This is our collaborative approach towards DevOps. We have a community. I'm going to share some more information about that in a little bit. So I don't know how many of you have been using AWS for as long as I have. I got started back in 2006. My first startup, Socialverse, is not around anymore. But we were accepted into the Amazon private invite-only beta for Amazon EC2, and it was pretty awesome. So we got started. We launched our app in there. The only thing was that there was a problem. The only thing that Amazon had at that time were M1 smalls, no load balancers, no persistent volumes, no RDS, no elastic hash, none of the stuff that we've come to take for granted today in Amazon. It was a brave world. Today, everything is infrastructure as a service, software as a service. We can write everything as code. We have software-defined networking. Lambdas, they blow my mind. We have gotten really good at practicing CI/CD everywhere, and GitOps is kind of the evolution of that. There's one area, though, that I think has kind of stagnated, and the status quo of that is how we actually deploy our infrastructure. And these have evolved into complicated manual rollouts that are done on the command line. And because of that, we have poor audit trails. I'm not even suggesting that somebody did something bad. I just want to go back sometimes and see what happened to understand what the current state is. And because of this, it's not really clear what's been deployed. And this leads to configuration drift, where sometimes, I'll go into a project and I'll run Terraform plan expecting 0 changes. And suddenly I see a whole lot of changes. And that's not making me feel good. So that combined with out-of-date documentation just results that no one knows what is going on or how to make changes. If you're using Terraform, we got a few more problems. And since not everyone here might be familiar with what Terraform is the preeminent tool for infrastructure as code. Terraform is what companies use to describe the state of their infrastructure across multiple cloud providers like Google or Amazon or Microsoft's Azure. And Terraform presents a pretty simple DSL that describes the state of your infrastructure. The thing is that deploying infrastructure is not really the same as deploying your traditional web app. And the reason for that is your traditional web app is usually stateless, while Terraform is actually responsible for managing this transition of states from one phase to another. Therefore, I like to think of Terraform more like a database migration tool than, like a traditional like Node.js app or something like that. And this is really important to Grok because if you start thinking about Terraform as a migration tool, I think it changes the way we approach it than trying to treat it or fit a square peg into a round hole. So Terraform plans, when you run those are really just a best guess of what is expected to happen when we run this configuration, when we try and deploy this configuration. And a result of that, Terraform applies, when you go to apply those changes, will regularly fail. This is the equivalent of like if you're doing a schema migration and you're adding a unique constraint to a column and then it fails your migration. So in Terraform, the same thing could happen if you're maybe referring to the wrong instance ID or the wrong VPC ID, or you're trying to do something that Terraform doesn't support, then it's going to fail. So the problem is that if we take the traditional approach to CI/CD and apply it to Terraform, what happens is if we merge to master and then deploy, chances are we're going to destabilize master, because if that deploy fails, master now does not represent the desired state. And if you have a busy development team, a busy engineering team that's forking off of this repo, now that error, that issue has proliferated across lots of branches, and we create a mess. So we're going to propose something that's almost sacrilegious in the world of CI/CD, and that's going to be that we're going to actually only merge to master when we have effectively achieved the desired state. And I'm going to show you exactly what that looks like. So to get people more on the same page here, let's say, I'm going to make some changes. And the typical workflow is that, on my laptop, at home, or in the office, I'm going to make some changes. I'm going to run a Terraform plan and apply, and everything's going to work just fine, because everything always works just fine on my computer. And then, I would never dare commit something or open a pull request that I didn't believe was actually going to do what I said it does. I mean, that's my honor on the line, right? But then launch day comes and we go to deploy these changes in production, and sure enough, something didn't work. And if we were doing this in the traditional CI/CD process, now we have this bug in master that just doesn't work. So why don't we try and avoid that from the beginning? And the reason why this happens is, it's pretty simple actually, is that we depend on a lot of different tools. And there's so many variables that are at play that any one of them could throw a wrench in the wheel for us. So when you factor in the number of tools like Terraform or Helm or the AWS client, or perhaps some external providers that you're using with Terraform, those all have versions and those all have dependencies. And then we're running these in different AWS accounts. And not all of our AWS accounts are going to be at the same version at the same time. So we have too many variables basically to account for. And there's no wonder that things go wrong in the end, because we can't control all of these things. So if we're trying to do all of this on our laptop, that's even going to be harder, because we have all these developers that have different configurations that we can't account for. So I'm going to argue that the last frontier that we're going to try and solve today is to stop deploying infrastructure to staging and production from our laptops. And the fix to this is going to make it very easy in the end for us to do Terraform, for us to make any team member on our team start making changes and deploying Terraform. I'm going to prove that to you because I'm not even going to drop to the console today in my demos to make this happen. So what is GitOps? Well, this is where we're taking Git as the system of record for the desired state of our infrastructure as code, basically our configuration. And when we want to make changes to that configuration, we're going to do that using pull requests. So any operation that we want to do, like increase the size of an auto-scaling group or to create a S3 bucket, we're going to do that by creating a pull request. And the very act of doing that is going to help us move the software from the process of showing what's going to happen to actually making it so. So basically, this is a way of doing CI/CD for DevOps. And my promise to you is that if you start practicing some of this stuff, what you're going to achieve are repeatable deployments. Basically, the way you do your changes every single time is going to be the same way. And you can even, deploy your whole stack at the same time this way if you wanted to. It's going to be predictable. And that's going to be that you're going to see a Terraform plan before we make any changes. And then when we go to apply those changes, we're going to apply exactly that plan that we had previously seen. And while this is no guarantee that it's going to succeed, it's at least a prediction of what the expected outcome is going to be. Like, are we going to drop a database? We don't want to do that. That would be a bad thing. And because we're doing this all through pull requests, it's going to be entirely auditable. We can see what was happened. When you get a new developer who joins, they can just go back and look at your pull request logs and see what happened, and and repeat that process. So that makes it accessible to basically anyone on your team that knows how to open a pull request. So the secret to doing all this is Codefresh. And why I really love Codefresh is it will literally let you automate anything. If you can stick it inside of a container, then it can run on Codefresh. So we can stick Terraform inside of a container. We can do CloudFormation inside of a container. We can do Helm. We can do Helm file. Because we can do all of that, we can do that inside of a container. Now, some of you might be using some other tools. Some of you might be using Terragrunt with your Terraform configurations, or some of you might not be using GitHub and instead you're using GitLab and Bitbucket. Or some of you might be using Ansible together with Terraform and Terragrunt. And yeah, all of that will work. We've seen it in action. So yes, Codefresh is yet another CI/CD solution. There are so many out there, my head spins. And what I think makes Codefresh stand out is it was built in the container era. So that is, it doesn't have all that legacy cruft built up from before we did things in containers. And if you, as an organization, like using containers, then this is the tool for you. So, it automatically supports Slack notifications, approval steps, GitHub comments. I'm going to show you all of that. So how are we going to run Terraform now inside of Codefresh? Well, it's going to be the standard Git workflow that you've seen before. Basically, a developer makes his changes in a feature branch, opens a pull request that gets, triggers a webhook in Codefresh, and then Codefresh goes ahead and does its thing where it runs Terraform, and when we get a plan, and then we post the output of that back to GitHub as a comment. And this process that I'm describing is basically what we're dubbing interactive pull requests. That is that we're using pull requests almost as a way to, as a terminal console, only that it's audited. And if you're not familiar with what the Git workflow is, it looks something like this. We open up a feature branch, we make our changes there, we push that up to GitHub, we open a pull request, and that then we assign that to somebody else to review it, so they can spot check it, see if anything's wrong, and that kicks off CI/CD and all that other stuff, and ultimately we end up merging to master. All right, so what does this actually look like now if we're going to go deploy some Terraform code? So here it is. I've opened up a pull request. I'm going to create an S3 bucket. And this is a really common thing, right? Your developers, they need a new bucket so they can upload image artifacts somewhere, like avatars, or you want to store build artifacts somewhere, or something like that. So this is really common. And you create a resource, we see the diff there. And the very act of opening up that pull request kicked off this webhook that triggered a execution in Codefresh that runs a Terraform plan. And we see what that comment is on the left-hand side. That is what happened. That is the comment that was posted back of what happened. And we can expand that show output and see exactly what is expected to happen. In this case, create an S3 bucket. At the same time, when that plan finished, what happens is we send a Slack notification to a shared Slack channel with a link for an approval step. That is, now if this pull request looks good and the plan looks good, then we can click apply, and then it actually goes and applies those changes. And it looks something like this. So basically, we run a Terraform apply that succeeds. We're rewarded with a little pat on our head, and we see what happened here. The bucket was created. So I'm going to now go ahead and show you what this looks like in practice in just a moment here. But behind the scenes, this is what was going on here. So Codefresh, we had a pipeline set up. We had a number of stages configured, a preparation stage, an initialization stage, a plan stage, and an apply stage. And in each one of those, we had a number of steps that we ran. And I'm going to show you exactly what those steps are in a little moment. All in all, that was pretty easy. And I would benefit from having this kind of process. So to get started, basically, you need to have a Codefresh account, and then you need to add a Codefresh pipeline to each of your Terraform projects that you want to be working with. And there's a little bit more configuration in terms of setting up your environment variables and stuff like that. But high level, that's about what's left to do. So here is what our Codefresh pipeline looks like. I've pulled out some pieces that aren't really essential for this demonstration here, but I'll link you to the complete pipeline at the end of this presentation. So the init step, this is where you run Terraform init. And I want to point out some things here that a lot of people always ask us. One is, how do we get secrets into our Terraform environment? Well, our answer to that is we use Chamber. So we have a namespace where we put all of those secrets. In this case, it happens to be called Atlantis because we also use Atlantis. And in that namespace, we have things like our private SSH key. And this is how we can access private Git repos from within Terraform, from within Codefresh. So what we're doing here is we're exporting those as environment variables. I'm starting up an SSH agent. I'm adding my SSH key to the SSH agent, and then I'm running a Terraform init. So then we're doing a Terraform plan. And those who are astute here will notice that I'm not specifying explicitly the out parameter to the Terraform plan. And that's because behind the scenes, we're actually exporting some environment variables that Terraform knows how to look for. And when Terraform sees those environment variables, it automatically knows to write an out file. So just be aware that we are doing that behind the scenes. Anyways, going through this here, some things I want to point out is the image. So what we do is we build an image for our infrastructure repository. And that image has like Terraform, it has Helm, it has, what else? We use the AWS client in there, we have Chamber, we have the AWS Vault command. We have a lot of commands in that thing. And what I'm talking about is actually something we call geodesic. So geodesic is a cloud automation shell. And while we use it, and we're going to use it for this demo, it's not a requirement to do what I'm doing. It just makes things a whole lot easier. All right, a couple things to point out if you are doing this. Terraform has this option where you want to have detailed status codes. And when you enable detailed status codes, then you have these exit codes that are 0, 1, and 2. So basically 0 is success with no changes, 1 is an error, and 2 is success but with changes. So just be aware of that. Then we run a Terraform apply. This is also going to use that out file that we generated in the previous step and apply exactly that. One thing I want to point out is that when you're doing Terraform, you are most likely going to leak some information that you might not want to have in your logs. And there's just no way around this. For example, if you use the random ID provider and you're using that for like a webhook secret, or you're generating some passwords, or if you're using the GitHub provider, all these things leak information to stdout that you might not want to have in your comments or in your build logs. Therefore, we wrote a program called tfmask. It's open source and it's on our GitHub. It's in Go, we distribute a binary, very easy to then filter that output and eliminate the secrets that you don't want. Lastly, we post the results of that apply back to GitHub. I'm going to show you what that looks like, but just be aware that GitHub Commenter, also an app that we wrote and available on our GitHub. All right, so we are at the exciting point where I'm going to show you a live demo. Actually, I'm not going to show you how to add a user. I'm going to add a S3 bucket in this demo. I'm going to open up a pull request, run a plan, and show you how I can approve that and apply it and merge that. All right, so stay tuned. So for this demo to be really effective, what I want to do is never leave my web browser. And I'm going to go to our testing repository. And you can follow along. This is a public repository. And in here, I have a previous pull request. Going to, I'll just leave that open for now. All right, so if I go into our comp folder, and if I go into our example here, and main, here you can see a very basic Terraform example. We create an S3 bucket. We indicate that we're going to use remote state, and we're going to assume a role that's required to achieve this outcome. All right, so gonna run, let's see. So we're gonna edit this file. So in this case, I've actually provisioned this in somewhere else. I haven't merged it yet. Unfortunately, I didn't reset the demo perfectly here. But let's call this a new bucket that looks something like this. And when I commit these changes here, it's going to create a new branch for me automatically, and indicate that I can create a pull request here. All right, so the act of doing this, let's make a, create new S3 bucket. All right, there we go. So the act of doing this, we now have the pipeline kicked off here, and I can click on the details here, and we can follow along with what's happening. All righty. So the first step, we clone that repository. Behind the scenes is just doing a git clone. We're building the Docker image. So this is the Docker file that you see in our testing.cloudposse.co repo. You'll notice that that Docker file inherits from another Docker image called geodesic. That's also open source. It's at github.com/cloudposse/geodesic. Check it out. Here we're canceling any other builds that might be holding, or any, not builds that are running, but any other builds that are waiting for approval. Basically, we are now running this pipeline, and if there's another pull request on this same project, then we want to cancel that approval step, because that's invalidated now. That doesn't matter anymore. Another thing I want to point out here is this pipeline. So typically in Terraform, what you end up with is a mono repo architecture. That is, you have one repository with a lot of different projects, and those individual projects have their own state, Terraform state, and they have their own SDLC, software development lifecycle. What we recommend you do is create one pipeline per project folder, and that way you can detect changes when only that project changes, and then you also have your Codefresh build history for that project. So you can see if it's been stable or not stable in the past. So here we've done some things. One of the things that we use a lot is direnv. So we've added support for direnv in our Codefresh pipeline. The reason why direnv is really nice, especially in combination with Codefresh. All right, so this failed. I did not make my sacrifice, but I know the fix here. What I need to do is basically update the STS credentials on Codefresh. All right, cool. So forgive this lapse. I'm going to restart. This is actually even pretty cool because what I can do is restart from the failed step. So I meant to do that. Just kidding. All right, let's see it go through the motions here. All right, so it's going to pick right back up where we left off. With a Terraform init. One of the things that's pretty nice with Codefresh is I can click on any one of these steps and I see exactly the YAML configuration that applies. We can see this, as you saw, we can see the scrolling output that you're familiar with Jenkins or any other modern CI/CD system. If I go up here, you see this is where we started the SSH agent and then we added that identity to it. That's how we're going to be able to pull private repos if we need to. This demo is actually only pulling public repos. All right, so that succeeded. And now we're running a Terraform plan. So let's look over what happened here. So the Terraform plan is that we're actually going to destroy and create a bucket. And we're going to destroy the old bucket because I didn't reset my demo, my fault. And then we're going to create a new bucket that is called example1. And this is the expected output. So Terraform exited with an exit code of 2. Remember, that means that there are expected changes. And then we posted back a GitHub comment. So now if I go back to GitHub here, oops, wrong pull request, I think. Yeah, here we go. So this is the pull request we just did, updated a minute ago. I want to point out some things. You see that this status here is pending. That's because we haven't actually applied everything. And I think this is actually a beautiful outcome because we don't want to merge something that hasn't been applied. And then we get that. So here's the comment that was posted. We have a badge that quickly lets us identify if there were changes. So when you're looking at this at a glance, you can immediately ascertain what happened. And then you can expand the output to see what happened. And here we see the same thing that we saw in Codefresh. Now, we didn't have to post this comment. Yeah, we could click on that link to view the build logs, but the whole thing here is that we want to make this blisteringly easy for others to see what's going to happen so that they're involved in the process and we have a good audit trail of what happened and what transpired. All right, so then at the bottom here, we have a couple links here that I can click on to approve this pull request. But I can also go over here and look in our CI/CD channel, and here's the same thing. So here's a notification asking to approve this pending plan. So I'm going to go ahead and approve that plan. Which takes me over to Codefresh. And behind the scenes, it's approved that step. Now we see this apply changes step has gone to approved, and we see who it was approved by. Now, if you wanted to restrict who can approve these things, that's also possible. You would add that logic to the pipeline itself, and yeah, so that would do that. All right, so it's now what happens behind the scenes, it spins up a new Codefresh container, and here we go. It's now running the Terraform apply. We see the commands that it execute. And all right, so it added one, it destroyed one, and we're all good, and it posted a comment back to our GitHub. So here we go, all good. So here we can see the same output. that we saw previously in Terraform. Now, one of the things I want to point out is that this output was very clean. And the reason why it's so clean is we use another project that's open source called Scenery. For those of you using Terraform Landscape, it's very similar to that, only it's not written in Ruby, it's written in Go. So it's a single binary you just drop in. And I really like that. All right, so at this point, we would be good to merge this pull request. If I get a final approval, then I can go ahead and merge this pull request, and we are set to go. All right, so that's that process there. I'm going to drop back into my slides here. All right, so the demo gods were relatively gracious today. Everything worked smoothly. So here are some of our best practices if you guys want to implement Terraform with GitOps. And one is check out our geodesic shell. This is a Docker base image that we use across dozens of customer implementations across all of our own infrastructure. It's totally open source, actively maintained, hundreds and hundreds of pull requests against it. So check it out. Use STS credentials in Codefresh for your tokens. For other customers, we have automated that process, so we're generating those automatically with a scheduled job in Codefresh. For this demo you saw, I went to the shell and I just ran a command to upload those credentials, but you can automate that too. Use GitHub code owners. So this is a way to require that specific individuals review changes to parts of your code before you merge to master. Use Terraform variable files, TFVAR files, for your settings. This way you can very easily track configuration settings between environments, but don't stick your secrets in there. Instead, stick your secrets into the SSM parameter store. Yes, you can also use ASM, but the tools for SSM parameter store are a lot easier. You can just use Chamber to write them. And then Terraform actually supports natively reading from SSM. So it's a really great way to track your configuration information in a secure way. Use Scenery to format your Terraform plans for CI/CD, and then use tfmask to sanitize the output so you don't accidentally leak some secrets in there. So it all comes down to one thing here, why we care about doing GitOps. And what you're doing is you're enabling your team at large to work on infrastructure. And that doesn't mean that everyone has to be an expert. That doesn't mean that everyone is down in the trenches writing Terraform modules. But what I like to see in an organization is you create a service catalog, basically a library of Terraform blueprints that has everything you need to deploy your infrastructure. And GitOps is what enables that. So I argue that if you practice GitOps, you're going to stop living dangerously. You're going to be able to practice total transparency in your operations, enable any team member to participate in the operations process without risking destabilizing your production environments. In fact, if you practice GitOps the way we've shown, you can actually almost eliminate everyone who has access to staging and production. That means that every single change is gated through your pull request process on GitHub. And I think that's a really powerful value add. The result of all this is increased productivity, less toiling, simplification of maintenance, because you can look at what you need to do through pull requests and guaranteed repeatability. So now, there was a lot of information here, and I can't possibly try and cover all of this in 45 minutes. I'm sure you're going to have questions, and if you do, we have just the place you want to go. Sign up at slack.sweetops.com. We have a community of over 700 members. Many of them are using the tools that we have talked about today, and it's a great place to talk shop with other DevOps professionals. The links for today are available here. You can also message me when you join the Slack channel if you miss any of these. So go to cpco.io, Codefresh GitOps. That's going to redirect you to the repo that has this demo. Check out tfmask. Even if you're not going to use Codefresh, even if you're not going to do everything else I talked about, you will want to mask your secrets. Even if you're using Jenkins, this is probably a good idea. Use Geodesic as your automation shell. and use GitHub commenter to write your rich comments back to GitHub. Now, if that's still not enough and you want even more hand-holding, more prescriptive advice, that's what we're here for. This is our bread and butter. We talk to our clients just like I've talked to you today, and tell you how to do things, go through your problems, unblock your team, and help you move faster so you spend less time spinning your wheels, and get a pulse on what other companies are doing, basically what the industry trends are. So do check it out. If you're interested, hit me up. My email address is going to be on the next slide here. So yeah, or maybe my email address, yeah, there it is, hello@cloudposse.com. Email me there if you have any questions. We're gonna turn this over now to Q&A.
Awesome. Thank you so much, Eric, for that great presentation. I just want to remind everyone that this is being recorded, and so I will send all of these slides and the full recording out to you by the end of the week, so you don't have to worry about jotting all these down right now. But I do have a few questions. What happens when your plan doesn't have changes? Does the dev typically modify the pull request and the build reruns?
Yeah, so I would still recommend, just to be pedantic about this, always follow the plan and then apply workflow. So even if it says there are no changes, I would apply no changes. And then there's a guarantee that that is exactly what happens and what happened. And then you merge. So yeah, I wouldn't introduce a decision there.
Sounds good, thanks. And are the CodeFresh pipelines themselves definable as code? So
Yes.
that way changes to the pipeline configuration are also done via pull request, etc.
Yeah, so that's a great question. And the answer is yes and yes. So there are a couple things here. So if I go to GitHub Cloud Posse testing.cloudposse.co, I'm gonna guide you to exactly where you find this demo. I go to the CodeFresh folder, I go to Terraform, and here's the pipeline. So this is defined as code, the pipeline itself, but now there's other things. You might want to define the configuration of the pipeline itself as code, and that is a different thing. And yeah, we have an example of how you can do GitOps of your pipelines themselves here, and that's under our Cloud Posse CodeFresh directory. And here's where we then have a bunch of templates, an example of how to, here we define a template of how a pipeline is configured with CodeFresh. If you are familiar with Kubernetes, you'll notice that the CodeFresh configuration, or basically the API, uses something that looks very similar to a CRD, custom resource definition. So you can basically submit CRDs to create your CodeFresh pipelines.
Awesome, thank you. And I have another question from Dan, and he says, and bear with me for just a moment, this is a little long. It looks like you're deploying your infrastructure separately from your application code. That is to say, you'd have one repo pipeline that generates new infrastructure and maybe a separate pipeline that deploys new feature code. But what if we want code and the new infrastructure that depends on it deployed as an atomic unit? That is, I want both the new database table and the code that references the table to reside in a single repo and be deployed simultaneously.
Yeah, that's a good question. It comes up all the time, and I have to clarify this point. So some of you are familiar with the OSI model, and it describes like layer 1, layer 2, layer 3, layer 4. Well, I want to describe the SuiteOps layer model. And that's basically that you have 4 foundational layers. You have your infrastructure layer, and then you have the infrastructure backing services. So your infrastructure layer are like your AWS accounts. It's your SSO integration, like with Okta. It's your credit card. That's a pretty good backing service right there. You need that to run everything else. And then on top of that, you have your next layer. You have your platform layer. This is kind of like where you run your Kubernetes clusters, your backing services for your Kubernetes clusters. So if you're using kops, it's going to require S3. It's going to require a Route 53 DNS zone. It's going to be where you have maybe some ACM certificates and stuff like that. And then on top of your platform layer, you have your third layer. And this is your shared services layer. This is where you run maybe, well, if you're running CodeFresh Enterprise on-prem, you would deploy it there. Or if you had Jenkins, or if you had maybe Prometheus, Grafana, you'd deploy that on the shared services tier. And then lastly, we have the fourth tier, which are your applications and your application backing services. Now, each one of these layers that I described has their own software development lifecycle. And to try and achieve every single one using the same exact tool, using the same exact workflow is an unrealistic expectation. So what I suggest is to treat each one of these separately and develop a CI/CD workflow that works for that use case. What I described today is, was more like a layer 3 example, to your point. And we could do the same thing though for your application. And you would basically create a Terraform directory in your application. And in there, you would have a pipeline that describes the Terraform for how to do it. Or in Codefresh, one of the cool things you can do, let me go back here to this example here. So here's my configuration for the example pipeline. And you can see that I have some shared environment variables. These are the secrets for AWS credentials and my GitHub token for the comments. But down here, there are 3 different ways to reference your pipeline as code. You can have it inline, which is great for like debugging. Like if you're just iterating, you don't want to have to commit every change and you want to rapidly iterate, that's perfect. But then when you're done with that, you commit that back to your source control. And then you can say, use this from the repository. So here's where you create a Codefresh directory, you have Terraform in there, and then you have your pipeline. Or you can have a central library of your pipelines, and then you can refer to your pipeline using a URL, and that's very dry. So that's a couple options. So imagine if you had a polyrepo architecture organization, you had all your apps, and your apps have some Codefresh dependencies. You would then register an additional pipeline for the Terraform component like this. So you can have any number of pipelines associated with your repository. Well, that is like more higher level explanation of how you would address that. I hope that explains the question.
Awesome. Thank you, Eric. And my next question, I have 3 more to go. A reminder, if you have any more questions, please enter them in the Q&A section. And also please answer that poll and let us know how we did today and how we can improve on future webinars. It might be in a separate window kind of behind your current one. Okay, my next question is, does the bot handle competing PRs? What if pull request number 1 makes some changes and PR number 2 makes some other changes? PR number 1 merges and the Terraform plan for PR number 2 changes?
This is a really good question, and this is a difficult problem to solve. If you're familiar with like Terraform Enterprise or Atlantis, which is a alternative CI/CD solution for Terraform, it handles those use cases. So in this particular demo, it's a little bit naive in that sense, where if I look at the pipeline here, we have one safeguard right now, and that is for a given pipeline, for a given project, we only allow the most recent plan to win. And that should address most things. So the way we organize, let me show you how we organize one of our projects here under testing.cloudposse.co. So, oops, wrong folder, conf. So under conf, this represents one of our account stages. Remember, we never share stages within one Amazon account. So we have a production account, we have a staging account, we have a sandbox account, we have a testing account, et cetera, et cetera. And then in here, we have our Terraform code. And we keep it very dry by using this nvarc pattern. So basically, we specify the remote module that should be initialized here. And we use Terraform init to do that. Now, what we have in here is essentially a mono repo. And each one of these projects has its own SDLC. So what we would do is we set up a Terraform pipeline for each one of our projects. And then we never modify more than one project per pull request. So they're kind of like checks and balances you can do. And remember, since, okay, let me show you how I implemented that, just to show you how much of a Swiss Army knife this is. So go into Codefresh, go into Terraform, go into pipeline. All right, so why Jenkins has been so popular for decades is partially because it's a Swiss Army knife. Like, there's nothing you can't do with Jenkins, right? And I almost argue the same thing is true with Codefresh. So here's a step where I have a cancel step, and I just define some commands to run as part of my pipeline before this one runs. And what this is saying is, get a list of all the builds that are in pending approval. So there's a plan waiting. and for my current pipeline. So if I'm looking at the example pipeline, it's going to find all example pipelines that are pending approval and then cancel those. So that leaves us with only at one time one pending plan. I'm not going to say that it's going to solve all the problems, but it's going to eliminate a fair bit of them by following that.
Thanks, Eric. And I just have a couple more questions. Looks like we have 10 more minutes, so we can squeeze these in. Is this container agnostic?
Container agnostic. So I mean, yeah, I mean, there's a lot of stuff in our Docker container. I don't want to beat around the bush. Yes, we use Geodesic. Geodesic has a lot of tools, a lot of things in there. You can run Geodesic anywhere. You can run containers. And if you don't want to use Geodesic, you can create your own container. You can stick Terraform in there. You can stick Scenery in there. You can stick tfmask in there. You can stick GitHub Commenter in there. You can stick all the other tools you're going to want to use. We also, like here, we're using JQ is another command. We use the Codefresh command. So there's, if you want to manage that, you can totally manage that, or you can just use Geodesic.
Okay, thanks. Then I have second to the last question here. How would I integrate Codefresh if I already have pipelines with Terraform Jenkins? Does Codefresh replace Jenkins in this scenario?
So we personally don't have consulting experience bridging Jenkins with the Codefresh world. We typically go all in to one environment or the other, just because it's really hard to specialize in multiple systems. So you can totally trigger a Codefresh build from your Jenkins pipeline just by calling a webhook. So if I go back here into Codefresh and I go to my example here, and here, so here's the curl command. I just click copy, stick that in my Jenkins job, bam. It's gonna fire off my pipeline in Codefresh. So it's very easy to stitch Jenkins with Codefresh or any other CI/CD solution. Where I think this is pretty neat is if most companies have a pretty large investment already in their CI/CD solution. They might want to move over to Codefresh. What this helps you do is bridge that gap until you get everything over, so you can marry those two worlds.
Awesome, thank you. And our last question.
Yeah, okay, so there's a few ways to handle this, and it's pretty interesting. So first of all, I want to point out that you might use Terraform to terraform stuff that is in private environments. And if you are using Kubernetes, then there's a really beautiful solution here, because what you do basically is you can deploy something called Venona. Venona is the runtime agent for Codefresh. This is like the Jenkins slave that you can install somewhere, only this is even easier to deploy if you run Kubernetes. And then you can deploy that in each one of your clusters. And we typically always run like a staging Kubernetes cluster for all the staging apps. And then we run a production Kubernetes cluster and a corp Kubernetes cluster for shared services. We don't use the same Kubernetes cluster for all environments, because then we're not dogfooding changes to other staging environments before they go to production. Like if we want to tune changes to Kubernetes, we want to do that in a sandbox type environment. So so the reason why I bring all that up is then here I would select basically the environment where I want to run this Terraform job in, and it'll go there. Now, if you're talking about how do you move changes from dev to staging to production, there's no one way to do it. There's no right way to do it. I can only talk about our way of doing it. And the way we do it is under Cloud Posse Terraform root modules. This is our service catalog. This is an example. This is like a reference architecture almost of blueprints for Terraform that implement things using all of our Terraform modules. So like if we want to deploy Datadog, here's an example for that. If we want to deploy EKS, here's an example for that. If we want to deploy COPS, here's an example for that. If we want to deploy all these things. Okay, so here's our service catalog. And this is what we version religiously. So every single merge to master, we cut a new release, and that allows us to do surgical version pinning. Then we have all of our infrastructure. So like if I want to go to our prod account, here's our prod.cloudposse.co repo. It's a little bit behind some of the other stuff we do. Then let's see, oh, actually, I'm going to go into root.cloudposse.co. This one's more current. So go into conf and go to like accounts and Terraform vars. Let's see, users actually, there we go. So here, so this is the root account. We're initializing this user configuration with our users module in our service catalog. It's pinned to 0.5.3. So when we want to move a change across environments, what we're doing is we're opening a pull request in each environment we want to introduce that change. This we find that this is a beautiful way of doing it because it enforces that you have a smaller pull request, and it enforces that you never try and update two environments at the same time. So you're strategically or deliberately moving changes from one environment to the next.
All right. Thank you so much, Eric, for answering everyone's questions. And thank you, everyone, for attending. Also, want to remind everyone that you can create a free CodeFresh account. You get 120 builds a month on our free tier. So go to codefresh.io and create that account. And join the GitOps Slack community that Eric mentioned earlier. So again, thank you so much, Eric. That was an incredible presentation. And we thank everyone for attending, and we will see you next time on CodeFresh Live. Bye, everyone.
Thanks, guys. This is great. Appreciate it.